Hello class, this video is about law of sines. Now previously you've learned about finding missing information from triangles using SOHCAHTOA, and we know that since the sine of the angle is the opposite over the hypotenuse, we can use that to set up a proportion here and then use that to find missing information about triangles. But what if it's not a right triangle? If it's not a right triangle, then you cannot use SOHCAHTOA to solve. Whenever we have an oblique triangle, we can solve the triangle by using the law of sines. Okay. So it becomes important that we label the triangle in the correct fashion. So when you're looking at these triangles, notice that the capital letters are all the angles, measured in degrees, right? Or radians. So we have the angles are capital letters. The lowercase letters are sides, and those could be measured in any length units like inches or meters or something. Now notice how we have a capital B, and then coming directly opposite from that is the lowercase b. They have to correspond. Across from the uppercase A is the lowercase a. So they have to be, the upper and lowercase have to be opposite from each other. And if you look at the information you're given and you know one pair of uppercase and lowercase letters, like maybe you know the angle C and also the side C, that's when you'll be able to use the law of sines. Use the law of sines when you know one pair of uppercase and lowercase letters. The law of sines says that the ratio of the length of the side to the sine of the angle opposite that side is the same for all three sides of a triangle. So if we have a side and we have the sine of the angle opposite that side, that ratio is equal to the ratio of another side over its sine, or we could use the third side and its sine. So that is the law of sines. Now, to use this, what you're going to do is you're going to pick any two, like you're just going to set up a proportion, maybe not using that one, just using 2, and then you're going to cross multiply. You're going to pick any two, you're going to cross multiply and solve. And so that's how you're going to use the law of sines. Let's practice doing that. Alright, so let's see for this example if we can solve the triangle where angle A is 46 degrees, C is 63 degrees, and the side C is 56. Okay, so here I've drawn a generic triangle to start us off with. Let's label the information we know in the triangle. Alright, make sure that you get the right side being 56. The 56, that's the side C, needs to go right across from the angle that's side C. To set up the sine law, we have to use the angles and the sides that are opposite each other. So I can see that the 63 angle is directly opposite the side 56. So I'm going to say 56 over sine 63. Okay, now we need another pair of corresponding. Let's use this 46, this angle A, and we'll use it to find the side that corresponds. Up here would be side A. So I'm going to use the sine of 46 with the side A. I have the side A over the sine of 46. Now I'm ready to solve this by cross multiplying. Crossing one way gives us 56 sine 46, and cross multiplying on the other side gives us A sine 63. Now, to solve for A, I need to divide both sides by sine 63. A is 56 times the sine of 46 divided by the sine of 63. And I can put that in my calculator to get the answer. So, now I have 2 of the sides and I have 2 of the angles. Solving the triangle means I need to find all 3. So, let's find the missing angle here next. Okay, since the angles add to 180 degrees, I can say 180 minus 63 minus 46 will equal angle B. So angle B is 71 degrees. Now let's find side B to match that. I'm going to use the same proportion that I already had with the 56 and the sine 63. Now we're going to use the 71 was directly opposite from what we're trying to find here, side B, equals B over sine 71. So now we cross multiply, and actually guys, whenever we're doing this, the sine rule, the steps for solving here are pretty much the same every time. First you cross multiply, then you have to divide by whatever's next to the variable, okay, and then we can get our answer. So let's cross multiply. We have 56 sine 71 equals b sine 63. Divide by sine 63. Putting that in my calculator gives that b is 59.4. All right, great. So now for my triangle, I have found all of the angles and all of the sides, so that means that I'm done solving my triangle. Great. All right. Okay, let's see if we can solve this triangle where the angle A, the capital A, is 40, lowercase a is 54, and lowercase b is 52. Okay, so to set up the sine rule, we're going to use the two that are directly opposite from each other. Let's put 54 over the sine of 40. And that will equal our second side that we know is across from the angle B. So let's let that be the variable that we find first. Let's find this other angle. So now I'm going to have the side, which is 52, over the sine of the angle that we don't know. All right, so let's go ahead and cross multiply in order to solve. All right, so now we can divide both sides. This time we need to divide both sides by the 54, since that's what's next to the sine b. Okay, so the sine of b equals 52 sine 40 over 54. Let's go ahead and put this part in the calculator so we can get a decimal. Okay, now we have one step left here to solve for angle B. In order to make the sine cancel, what I have to do is take the inverse sine of both sides. So I'm going to take this entire thing and I'm going to take the inverse sine of both parts. The inverse sine of the sine cancels out to give me b equals the inverse sine 0.738, which happens to be, or if we round to the nearest degree, let's just say b equals 48. So that means that angle B could be 48 or 180 minus 48, 132. This is a very surprising thing, that sine would have two solutions between 0 and 180. So let's take a minute to pause this problem and talk about how to solve when we have sine, how to solve from here. All right, when we're solving equations that have sine, the first thing that we had to do was we had to take the inverse sine. And the inverse sine was that sine with the little -1, right? So that's that -1 means inverse. It doesn't mean up to a power of -1. So we take the inverse sine. And then we had to subtract from 180 degrees because the sine has two answers. Remember that the sine is kind of like the y value of this point. This is like a unit circle here, right? Well, this point has a y value here, right? But symmetrically, there's another point on the unit circle whose sine would also have that same value, that has the same y value. So we have to subtract from 180 in order to find both those solutions. So that means that when we're solving these problems using our sine law and we have to find the angle, a couple different things could happen. First, we could have a problem in which there is no solution. No solution happens whenever the value that you're trying to take the inverse sine of is greater than 1. Because think of a unit circle. What's the radius of that circle? It's 1. So none of the values should never be greater than 1. It's going to be outside the domain. So when you put this in your calculator, if the number that you're taking the inverse sine is greater than 1, your calculator is going to tell you that you have an error in your domain because that you're outside of the restricted domain. Okay, you're outside of the domain of the unit circle, which is never greater than 1. All right, so if this ever happens, then you cannot solve the triangle. You're done. Okay, the second thing that could happen is you can, maybe it's okay, you took the inverse sine just fine, and you subtract from 180 and you get your two values. So sometimes what will happen is that one of those values of the angle does not make a triangle. Okay, so we know that the angles of a triangle have to add up to 180 degrees. So let's say you get one angle, okay, it's like 5. You subtract from 180 and you get the second angle to be 175. Well, you need to go back and check with each angle that if you use the angle that you have and the angle that you were given, that you can actually make the third angle so that the triangle will add to 180. Because if it adds to more than 180 degrees altogether, then it's not a triangle. So that means that that solution would not work. So maybe only one of your possible angles creates a triangle. Once you have done this and you find one solution that works and one solution that doesn't, you need to continue the problem. You have to do the sine rule again and continue to solve the triangle. All right, now sometimes both solutions will work. You're going to subtract from 180, find the other solution. Both solutions can make triangles that add to 180 degrees, so you have two solutions that work. Okay, so both possible solutions can make triangles that add to 180. So if that's the case, then you're going to have to solve both possible solutions. So you're going to need to solve each of the triangles. So do the sine rule twice, solving both triangles. All right, so now let's go back and look at example 2 to see what's happened. Okay, in example 2, we came up with two possible values for B. We found that B could be 48, but then we subtracted from 180 and saw that B could also be 132. So now we need to check to see whether or not we can actually make a triangle with this and whether or not we can actually make a triangle with these numbers. So subtracting from 180, is there a number that would work here that would make this triangle add to 180? And yes, this corner must be 92. So this value, 48, works. 132, does this one also make a triangle? Well, this corner would have to be 8. So yes, this one also works. So this time we're going to have two solutions because both possibilities work. So we need to do the sine rule one last time to find the missing side here. Let's call it C. So we're going to do the sine rule to find side C. So let's start with one of the ones that we already know. I already know this particular pairing, and you could use this pairing or this pairing because we know both already. I'm going to stick with the original one. Equals C over sine 92. Cross multiply, divide by sine 40, and put that in the calculator to get the final answer. We get 84 to be C. Okay, and now we're going to do the sine rule again to solve the other possible triangle. So we have 54 over sine 40 equals C over sine 8. Cross multiply and divide by sine 40 gives us our value for C. So we can put that into the calculator to get the answer for C, and this time C is 11.7. So I've solved both possibilities. All right, and that is how you use the sine rule.